My name is Gangga bin Zabudin and my registration number is AA232347.
Assalamualaikum. My name is Nurul Azhar. My matrix number is AA23029.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurfatihah binti Hadi and my matric number is AA23025.
Hi, Assalamualaikum. My name is Nurifah Syazah binti Arman. My matric number is AA23034.
Hecras. Hecras is Hydrology Engineering Center's reverse analysis system. It's a powerful software package used for hydraulic modeling and analysis of river systems developed by the U.S. Corps of Engineers. It simulates a wide range of river conditions including steady and unsteady flow, backwater effect, and sediment transport. Hecras is widely used in flood control and river engineering projects.
I will explain the methodology used to develop the Hecras model for our river system analysis. The process is divided into three key phases: river schematic setup, data input and modification, and finally the model setup for flow analysis. We begin by using the provided Excel file, which include crucial inputs such as river schematic coordinates, detailed cross-section data, boundary conditions, and flow information. These datasets were systematically entered into the Hecras software to perform both steady and unsteady flow simulations. This step laid the foundation for the entire hydraulic model. Next, the schematic and cross-section data were automatically imported from Excel into Hecras. This geometric data forms the structural basis of the river model, include channel width, stream slope, overbank geometry. These inputs ensure that the model accurately represents the river's physical behavior under different flow conditions. The average coordinate point used in the model was marked as XYZ, that is 0, 3, 4. Once the geometry setup was complete, we proceed to assign flow data into the model. For steady flow analysis, boundary conditions and flow rates were set as constant values. For unsteady flow analysis, we assign hydrograph to simulate change in flow over time, reflecting real-world events such as rainfall or upstream release. The river reach was bound both upstream and downstream. For upstream, hydrograph were applied under unsteady conditions, and for downstream, we use either known water surface elevations or normal depth values, depend on the scenario.
Hi, so now I will show how to use Hecras app. So first, go to file to create a new project. Okay, so we name as Hecras cross-section. Then click OK. Then we input the geometry data. First, we need to draw the upstream line randomly, and then name it as Lipes River, and the reach is Lipes upstream, and draw another one random line and name it as Tempera River. Then we give a junction as LT. For the coordinate, go to GIS tool and put the coordinate at this line, and then we click OK. Here is the real reach of river based on coordinate. Okay, next, insert the cross-section data. Insert the data based on the section. Then repeat the same times for Tempera River and Lipes downstream. And then we save the file. For the junction, we put 0. Okay, so we done for the geometry data. So we close the apps And then we need to make two copy, one for steady flow and one for unsteady flow. So we open the steady flow. Then we edit the file. For the lipase upstream, we put 2250. For lipase downstream, 3075 and 825 for tempera. And then click boundary connection. Then put the normal depth for lipase upstream, lipase downstream and tempera 0.001. And then click OK and save it. Okay, so we done for the steady flow. Next, we go to unsteady flow. Okay, we open the unsteady file. Go to hydrograph, data time interval, and we click 6 minutes. Fix start time and choose today date. Okay, and then we click OK. So we go to tempera and do the same step. And then go to initial condition, put the value that you like I put 1, 2 and 3, and apply data and save unsteady flow data. And then we need to run unsteady flow, and we need to choose the data with the same as the data that we choose the first, the date that we choose the first. And we can run the data. And so now we have we have done the unsteady data. So we have done for Hecras. This is the table that have all our data, and this is the graph for cross section and the graph for profile plot. That's all from our group. Thank you.
Okay, in this video, I will explain about that we found from using the Hecras tools that to study the river flow. Both are steady and unsteady. Okay, one is why we use the Hecras. Okay, we use the Hecras because it is a very useful tools and to model how the water move in the rivers. Okay, next we adjust the thing like manning and reach length to the match our river data and make it better. Okay, this make the model more accurate and realistic. Okay, second is about I said before, steady flow. Okay, steady flow is simple but limited, such as the steady flow give a fixed view, like a photo of the river at one moment. We can see it's good for the basic design work, but it doesn't work when we show the change over time. Okay, it's not enough for the real situation like flood or heavy rain. Okay, third is unsteady flow. It's more realistic. Okay, as unsteady flow show how the water change over the time. Okay, it useful event like rainfall, dam release, or sudden surge. Okay, we saw how water depth, speed, and flow rate change in the real time. Okay, then this we can much better understanding of what actually happen in the river when we use this unsteady flow. Okay, that is what is matter in the engineering, such as my course in civil engineering, for the flow studies, sediment control, or environment planning. And unsteady flow is more reliable. Okay, it helps the engineer to make a better and safer decision. That is more to accurate. Okay, and then the fifth point is learning and practice. Okay, this project also helps us to learn how to build and run a Hecras model. Okay, a good mix of theory and practical steps to help for both student and beginner in this field. Such as the beginner or medium or top student can use the Hecras to study or what. And then I will close this video with a short notes. Okay, steady flow is simple but limited, but unsteady flow is more complete and realistic. And the Hecras is great tool if you use correctly and with the right data. Okay, thanks for watching. Thank you.